Alright, so we have the equation of the circle C, given by the equation x squared plus 8x plus y squared minus 2y equals 0. And we were asked to show that the center and the radius of the circle C are -4, 1, and the square root of 17 respectively, which we have done. We have basically, we rewrite this equation as in the general form, which is right here. And we're able to prove that the center is -4, 1, and the radius being square root of 17. Now we want to look at part 2. And for part 2, we are showing that, or determine that the coordinate of the point, or should I say the coordinates of the points of intersection, all right, between the circle C and the line L, being y equals 4x plus 34. And then we are to state the relationship between the circle and the line. All right, so we're assuming that we only have one point of intersection, but we're going to see if it's 1 point or 2 point. If it's 1 point of intersection, that means it's a what? Then the line is a tangent. If it's 2 points of intersection, then the line is a secant. If it doesn't pass through, if there's no point of intersection, then it's neither a tangent or a secant. So let's look at that. So what we're going to do, we're going to take y equals 4x plus 34 and plug it in either into this equation or this one, because this equation here is the same as this equation here. So whichever one you use is fine. All right. Let's use the one that we would have gotten the general form. All right. So x minus, let's use plus 4. Subtracting negative is positive, but this is really a plus, right? Plus y minus 1 to all squared equals 17. And then we can replace y with what? Well, we're told that this y is equal to 4x plus 34. So where we have y in the other equation, we can replace it with 4x plus 34. So y is 4x plus 34. Then we're going to subtract the 1, put back the 1, minus 1, that is. Squared equals 17. Let's just write this back to see where we can go with this. And then we're going to get 4x plus 34 minus 1 is 33. Squared equals 17. Perhaps it would have been easy to just use this equation on top here, but I decided to go this route. So square of x. To expand this, we square the first term, get x squared. Then we multiply the first by the last and double. In other words, 4 times x is 4x, doubled is 8x. As we can see, we have the first two already. And then we're going to square the 4 will give us 16. All right. And then let's look at the other one. Square of 4x, that's be 16x squared. Now we're going to multiply 4x by 33. That is the first by the last and double. So 4 times 33. That's going to give us, so 4x times 33 is 132x. And if we were to double this, we would have gotten 264x. And then we square the last, so this will be 33 squared. That will give us 1089, what equals 17. All right, so let's tidy this up. So we have x squared, then we have the 16x squared. Let's put those together. The 8x, we'll have the x term next, plus the 264x. We have the 16 here. So we're going to have the 16 plus the 1089. I'm going to just transpose the 17. So that's minus 17 equals 0. And then subtract 17 from both sides. Okay, so this is going to give us 17x squared, 18 that's not 18, that's 8. 8 plus 2, 64. And that's going to give us 272. That's 272 x's. All right, so in other words, 272x. Then 16 plus 1089 minus 17. That's going to give us 1088. Okay, so we have some big numbers here. And if you want to think about this, we could either solve this through factorizing or the quadratic formula. But one thing we can always do when we have the equation, as we have an equal sign, equals 0 here, we can see if we can remove, simplify these numbers. 17 is a prime number, for instance. Only 1 and 17 can enter 17. But so the question is, can we divide each of these by 17? All right, and the answer is yes. If we divide 17 by 17, we get 1, so that's 1x squared. If we divide 272 by 17, we're going to get 16, so that's going to give us 16x. And we'll divide 1088 by 17, we're going to get 64. That's equals 0. And if we look at this, this is actually a perfect square, because this is can be written as x squared. This can be written as 8 squared positive, and this has to be a positive, right? This one doesn't have to be a positive, but since we have a positive 16, we can consider the x here and the 8 here, and write the middle as, since we have a plus here, we make sure to put a plus here, and we're going to be 2 times the same x and the 8. Right, let's put the 8 first, then the x after. All right, so once we can write it like this, look, x squared, which we have here, 8 squared, which is 64, and 2 times the first in terms of x, and the last 8. So 2 times x times 8. Now 2, 8, 16 times x, 16x. So we're seeing that we get back the same thing on top. Now once it's in that form, obviously, it can be written as, one moment. Okay, good. So let's see if we can actually put it over here. We can write it as a perfect square, which is going to be taking the first, which is the square root of x squared, which is x. The last taking the 8. No, the middle sign is a positive, of course, so we acknowledge that and take the 8. All right, and so that's it. In other words, if we were to go backwards, it's going to be the square of x, which is x squared, square the last 8, which would be 64, multiply the first by the last, so 8 times x, 8x, and double it, we get 16. Now once it's a perfect square, to solve this, we only have an x, right, in this case. So what we can do, we can square root both sides, which will give us x plus 8 equals, square root in this side will give us, of course, 0. Square root of 0 is 0. And then solving for x, we're going to get x equals negative 8. All right, so x equals negative 8. Now, in order for us to find y, what we can do, we can substitute the value of x that we found into the linear equation. All right, the linear mean the highest power on the variable will be 1. All right, either variables. So either the y or the x, power is 1 on it. So it's a linear. So we can substitute x equals negative 8 into the linear equation. Of course, we could substitute it into the this equation here, the nonlinear equation, but of course it's much faster using the linear. So we're going to write y equals 4x plus 34, and substituting the value of x in it, which is negative 8, we get y equals negative 32 plus 34, which gives us a positive 2. And so we have the point of intersection being x equals negative 8 and y being 2. And since we have only one point of intersection, right, because we didn't get two values of 8, because when we square root both sides, square root in 0 can only give us 0. If we had two different numbers, let's say we had a plus or minus. If we're taking the square root of this number over here and it's plus or minus whatever number it is, let's say the plus or minus the square root of 0, it still will give us 0. Or the positive negative 0 is still 0. So we only have one number. If we had two, then in that case, we'd have 2 points of intersection. I hope you got that, what I'm saying there. So the relation, since only one point of intersection between the circle and the straight line, right, wherever that straight line will be, so we have one point, then the relationship is a circle and a tangent, right? It's a tangent, basically. And that's it for question number 1.